This is the budding light of hope and knowledge, the delight of Sri Prakash Educational Institutions, spreading academic brilliance in all directions.
Welcome to Sri Prakash Educational Institutions online video content. This is a video on graphical representation of motion, volume 3, 9th standard physics, and myself T. Vinod. Instructions to follow. Be ready with your textbook, notebook and pen. Watch and listen to the video carefully. Jot down all the important points in your notebook. In today's agenda, we will learn the word of the day, recite the previous knowledge, learn to plot the distance time graph, calculate the speed from the distance time graphs, and summarize the content of the video at the end. Word of the day, representation. It is a noun, meaning the act of presenting somebody or something in a particular way. Conjugation, represent, represented, representing, represents. Usage, the farmers demanded greater representation in the parliament. The school's representation at state finals included many great athletes. Learning outcomes. Students will be able to understand the graphical representation of motion, identify the type of motion by visualizing the graphical representation. Students will learn to plot the distance time graph. Students will also learn to calculate the speed from distance time graph. Hello students, welcome to today's session in graphical representation of motion. In the previous sessions, you have been learning about the different terms in motion: speed, velocity, acceleration. You are familiar with the definitions as well as with the formulas. Now it is our task to represent the information on graphs. The first type of graph is distance time graph. So we will learn how to plot a distance time graph in this module. All the best. Thank you. Graph. You are familiar with the line graph, bar graph, and the pie chart. When a set of data measurements is presented on a graph paper, it is called a graph. Graphs are very attractive and effective means of presenting data. Even the most complex information is made simple and understandable with the help of graphs. Graphs facilitate a comparative glance at the data. We can analyze the data from the graph. Distance time graph. Time is always taken along x-axis. Time is independent variable which is made to change at will. We have the freedom to fix the time intervals. Distance is always taken along y-axis. Distance time graph. Case 1. Body moving with uniform speed. Let us plot the distance time graph from the data that is given in the table. At 0 seconds, the distance traveled is 0. Therefore, the position is at the origin. At 5 seconds, the distance traveled is 10 meters. 10 seconds, it's 20 meter. And 15 seconds, it is 30 meter. And 20 seconds, it's 40 meter. And 25 seconds, it's 50 meter. The result of the graph is a straight line having a slope with the time axis. Nature of the graph for uniform speed or uniform motion. It is a straight line having a constant slope with the time axis, which is the x-axis. Calculating the speed for uniform motion, let us consider two time intervals t1 and t2 and the corresponding positions along y-axis are s1 and for t2 it is s2. Now we can find the time period between the two intervals along the x-axis by subtracting t1 from t2, and we can also calculate the distance along the y-axis by subtracting s1 from s2. We know that speed is equal to distance by time. From the graph, distance is s2 minus s1 and time is t2 minus t1. We can also write like this. Speed is equal to change in y-axis. S2 minus S1 represents the change in the y-axis and T2 minus T1 represents the change in the x-axis, which is equal to the slope of the graph, that is delta y by delta x. Now we will calculate the speed from distance time graph. The time t1, at time t1, the position is s1 30 meters, and for time t2 the position s2 is 50 meters on y-axis. The formula for calculating speed from distance time graph is equal to slope of the graph. Slope of the graph is change in y-axis by change in x-axis. Now here along y-axis the change is s2 minus s1, and here along x-axis it is t2 minus t1. So s2 minus s1 by t2 minus t1. S2 is 50 meter minus S1 is 30 meter on y-axis, and T2 is 25 seconds and T1 is 15 seconds along x-axis. 50 minus 30 is 20 by 15, 25 minus 15 is 10. So you have the speed 2 meter per second. Hence we calculated the speed from distance time graph. The slope of distance time graph is equal to the magnitude of the speed of the moving body. Distance time graph. Case 2. Body moving with non-uniform speed. Let us plot the graph from the information provided in the table. For time 0 seconds, the position is 0, so it's at the horizon. 5 seconds, 20 meters along y-axis, 10, 30 meters, and for 15 seconds it is 50 meter, and for 20 seconds the distance covered is 55 meter, and for 25 seconds the distance covered is 60 meter. The graph is a curved line. Nature of the graph of a body moving with non-uniform speed. Distance time graph of a body moving with non-uniform speed is not a straight line but a curved line. Case 3. Body at rest. Let us plot the distance time graph for a body at rest from the information provided in the table. At 0 seconds, the position is 30 meters on y-axis. 5 seconds, no change in the position. 10 seconds, no change in the position, same 30. For 15 seconds, no change in the position. And for 20 seconds, it's again 30. And for 25 seconds, it's again 30. So the graph will be a straight line parallel to the time axis. Nature of the graph of a body at rest. The distance time graph of a body at rest is a straight line parallel to the x-axis, which is the time axis. Let us try to solve a sample question based on graphical representation of motion. This is a displacement time graph of motion of a girl going to meet her friend who stays 50 meters from her house. On y-axis, the displacement is plot in meters, and on x-axis, the time is plot in minutes. The first question goes here. How much time she takes to reach her friend's house? Her friend's house is 50 meters from her house. On y-axis, you can see at 50, we have this point G. So she is able to reach that 50 meters in 14 minutes. So the answer for the first question is she took 14 minutes to reach her friend's house. The second question is, what is the distance traveled by the girl during the time interval 0 to 12 minutes? On the x-axis, time 0 to 12 minutes. On the y-axis, we have the displacements. We will divide the time intervals for 2 minutes and the distance traveled between these time intervals separately. From 0 to 2 minutes, on y-axis we have positions from 0 to A, which is equal to 20 meter. And from 2 to 4 minutes, we have the representation from A to B, but there is no change in y-axis. AB represents a parallel line to the time axis. So this position is a rest position. There is no displacement in that particular time interval from 2 to 4 minutes. 4 to 6 minutes. There is a change in position from B to C, from 20 meters to 40 meters. So the distance covered is 20 meters. And from 6 to 8 minutes, C, D, they are in the same horizontal line parallel to the time axis. So there is no displacement during that time interval. So distance covered here is 0 meter. And from 8 to 10 minutes, there is a change in position from D to E, which is a downward slope from 40 to 20 meters. So actually it should be minus 20 if you are taking the direction. Since it is a distance, what are we writing is the difference between 40 and 20. It is 20 meters. And in the last 2 minutes, from 10 minutes to 12 minutes, E to F. So this is a horizontal line which is parallel to time axis and there is no change in the position. So this represents the girl is at rest. When we add all these displacements or distance covered by her, so it is total 60 meters she traveled in 12 minutes. Now the third question. During which time interval she is moving towards her house? In this question we have two different time intervals in which she is returning. From G to 16, this is a change in position in the backward direction, and this one is a change in position in backward direction. So from 40 she is returning to 20. We needn't consider the last case because she is returning back to her house. Since in the question it is asked which time interval she is moving towards her house. So we are considering the time interval in between her journey to her friend's house. So it is between 8 to 10 minutes she is moving towards her house is the answer. Now the fourth question. For how many minutes she was at rest during the entire journey? We need to check all the parallel lines. So the parallel lines between the time interval 2 to 4, that is 2 minutes here, and then the parallel line between C and D, so 2 minutes here, and then the parallel line between E and F, 2 minutes in this case. So she is at rest for total 2 plus 2 plus 2. So 6 minutes for the entire journey. That is the answer. Now the last question. Calculate the speed by which she returned home. We know her position when she is in her friend's house is G. So this will be her position in friend's house. So I will mark the 14 minutes as T1 and Y1 as when she is in her friend's house. We need to calculate the speed while she is returning back. So she took 2 minutes, that is at 16 minutes she is in her house. And then Y2 is her position after 2 minutes, which is equal to 0 meters. The reason is displacement becomes 0 as the girl has reached her house back. We can calculate the speed from the displacement time graph by finding the slope. You already know that to find the slope we use the formula change in y-axis by change in x-axis. So change final minus initial, so y2 minus y1 by x-axis we have time t2 minus t1. Now I am substituting the values 0 minus 50 by 16 minutes minus 14. So you will have minus 50 on the numerator and 2 minutes in the denominator. This negative sign indicates only the direction. So while calculating the speed, we can ignore the negative sign and you can write 25 meter per minute. You can also convert this into SI system, meter per second, by dividing 25 by 60 meter per second, which will be equal to 0.4167 meter per second. That is the answer for this question. Finally, we have reached to the end of this module. In this module, you have learned about distance time graphs, how to plot the distance time graph. In this, you have come across 3 different types of graphical representation. The first one is for a uniform motion. The graph for a uniform motion is a straight line having a slope with the time axis. So you can calculate the speed from this graph. If you find the slope of the distance time graph, you will get the magnitude of the speed. And the second type of graph is for non-uniform motion. So the distance time graph for a non-uniform motion is a curved line. And the third type is the graph for an object which is at rest. Here, in this case, the graph will be a straight line parallel to the time axis. So we have successfully completed the distance time graphs, which is one part in graphical representation. We have the other part, still more interesting, is the velocity time graphs. So velocity time graphs we will discuss in the next module. Till then, you practice the distance time graph from the questions which are given in the textbook. All the best. Thank you.